Let's start implementing the snack machine with the simplest method, return money. Creating another file, snack machine tests. We can call the test return money empties the money in transaction. I create a snack machine here and insert a dollar inside. And you can see the test doesn't like what we've done here so far. The problem is that we're trying to use the money in transaction instance without initializing it. That's one of the benefits continuous test running provides us. We get the feedback very quickly. Alright, so let's add a constructor, assign an empty instance to the money inside, and the same for the money in transaction. Good, the tests went green again. Calling the return money method and verifying the amount of money in transaction is 0. The test fails and now we need to implement the method itself. Here we need to somehow clear the money that are currently in transaction. The first option that could come to mind is to introduce a clear method and call it here like this. This solution is not the best one as it violates the immutability of the money class. In order to implement such a method, we would need to change the state of the existing money instance. A better way of dealing with it is to just override the instance with a new one, like this. This way, we are keeping the money value object immutable. You can see the tests are passing, so now we can do a bit of refactoring. First of all, creating a money instance and passing all 6 parameters to it all the time is a bit annoying. As our money class is a value object, it's a good idea to create a static read-only field for the empty money instance. Here it is. Now we can replace the constructor with this field. And it turns out we can create a field for each coin and note as well. Cent, 10 cent, quarter, and so on. This enables us to simplify our test like this. Another thing we can do here is we can employ the new features of C#6 and simplify our code even further. Static using statements allow us to import a separate class and use its static members without specifying the class name. So money.dollar here turns to just dollar. And we can do the same in the snack machine class. Another C#6 feature is property initializers. I can just assign the money instances the initial values and remove the constructor. Alright, another method we are going to cover with tests is the insert money method. We can call the test inserted money goes to the money in transaction. Creating a new snack machine, inserting a cent and a dollar, and checking the amount of money is correct. The test passes because we already implemented this functionality, but let's make sure the test doesn't give us false positive by commenting this line here. Very good, I can uncomment it back again. At this point, we need to once again think of possible edge cases. Is it possible to insert not a single coin or note, but several of them all at once? That is probably a question we need to ask the domain expert, because at this point it's not obvious if the model we are building should support such a use case. Remember, communication between the developers and domain experts is vital, and the domain-driven design practices put a great emphasis on this part of the development process. Let's say that we, together with domain experts, decided our domain should only accept a single coin or bill at a time. That makes sense because that's how a real snack machine's receiver works. So we need to add another test to verify that. Cannot insert more than one coin or note at a time. In the test, we need to create a 2-cent money instance and try to insert it to the machine. The test would pass if the machine throws an exception. Alright, to implement this, we need to specify all possible values we accept in the insert method and check if the incoming instance is one of them. Good. And finally, we need to finish the buy snack method. We can add a test named money in transaction goes to the money inside after purchase. Here we are inserting $2 to a machine, calling the buy snack method, and checking the money in transaction is empty and the money inside contains $2 after that. The implementation is pretty simple, we just need to assign the money inside instance an empty value here. We are done with the first draft of the snack machine. It obviously lacks some significant parts, for example, the buy method should definitely deal with snacks somehow and not just take all inserted money. We will address this in the later modules when we'll be discussing aggregates and repositories. Also, in a real-world application, you would probably want to write more unit tests. For example, it's a good idea to check that a newly created snack machine doesn't contain any money in it. But I'll leave it aside just to keep our development process less verbose. In the previous 3 demos, you saw how we implemented our first version of the money and snack machine classes. Note that we kept the money value object immutable. Whenever we needed to perform such operations as addition or subtraction, we created a new instance of the class without changing the existing ones. The snack machine entity, on the other hand, is mutable. Mutability is an inherent trait for all entities. They change their state throughout the lifetime while maintaining immutable and unique identity. Also note that the snack machine entity contains not as much logic compared to the money value object. All it does at this point is delegates most of its operations to the money class. This is another good practice I mentioned earlier. Always try to delegate as much logic as possible from entities to value objects. Value objects are easier to maintain because of their immutability. During this phase of development, we stuck to the TDD process, meaning that we wrote the tests first and then implemented the required functionality according to those tests. I intentionally demonstrated the whole process to show you how nicely domain-driven design can be combined with test-driven development. In the next modules, however, I will depart from adhering to the test-first approach just to speed our development up. But keep in mind that it's a good practice to follow this simple rule. Write the code first when you are experimenting with your model and switch to the test-first mode when you have a good picture of how the code should look like. And of course, while the test-driven development practices can be beneficial, you don't have to follow them in order to do domain-driven design. But remember to always cover your domain model with unit tests, regardless of when you prefer to write them. In this module, we started the development with the first bounded context, which is snack machines. We focused on entities and value objects. You learned the differences and best practices behind these two notions. Let's reiterate through the most important moments of this module. First of all, try to begin the development by working with the core domain first. Your core domain, along with the unit tests covering it, is the most important part of the application you are building. Secondly, always start the development with a single bounded context. There is little value in dividing your application into several pieces up front, as you usually don't have enough information to make a competent decision about the proper boundaries at this point. Constantly evaluate your code and look for hidden abstractions in it. If you see your code becomes unclear or convey its meaning vaguely, it's a strong sign you missed an important abstraction. There are 3 main distinctions between value objects and entities. The first one refers to the way we identify them. There are 3 types of equality when it comes to comparing objects to each other. Entities possess identifier equality, meaning that we treat 2 entities as being the same only when they have the same identifier. Value objects, on the other hand, have structural equality. We consider 2 value objects to be equal if all their fields are the same. Value objects cannot have an identifier. The second distinction is that value objects are immutable data structures, whereas entities change during their lifetime. And finally, value objects cannot live by their own, they should always belong to an entity. In our application, for example, the money value object doesn't make sense without a snack machine. A snack machine composes 2 money instances. It also means that value objects shouldn't have their own tables in the database. We will elaborate on that topic in the next module. We discussed the techniques for recognizing a value object in the domain model. A good approach here is to compare one to an integer. If they have essentially the same semantics, you can be sure the class you are looking at is a value object. We also talked about an important practice of moving as much logic to value objects as possible. Value objects are lightweight and, therefore, are extremely easy to maintain and reason about. We looked at the code of the base entity and value object classes, and also saw why we cannot use .NET value types to create value objects. We discussed test-driven development in the context of domain-driven design and two approaches to writing unit tests. We will talk more about unit testing in the following modules. Alright, we've made a good progress here. In the next module, we will see how to introduce user interface and a database in a way that helps keep our domain model clean and isolated.